Friends, fellow cosmic voyagers, I'm Demo, and tonight we embark on a journey that stretches the very fabric of our imagination. We often gaze at the night sky and wonder, are we alone? But perhaps the question isn't just there's life out there, but it might be hiding, and in what astonishing forms. What if aliens aren't hiding, they're just living on planets we can barely imagine? Giant lava worlds, gas giants with diamond rain, and even planets that orbit two suns like Tatooine. These are the strangest exoplanets ever found. And some of them could actually support life. The universe, it turns out, is a far more creative and diverse architect than we ever dared to dream. Each new discovery, each flicker of light from a distant star system, peels back another layer of cosmic mystery. We're not just finding more Earths, we're finding worlds that defy our expectations, worlds that challenge our understanding of what a planet can even. So, buckle up, we're about to venture to the frontiers of planetary science, to explore celestial bodies so extreme, so alien, they make our own solar system look almost tame by comparison. Our first stop on this cosmic safari takes us to a world that at first glance might feel tantalizingly familiar, yet profoundly different. I'm talking about Kepler-22b, a planet orbiting a sun-like star, G-type much like our own. Discovered by NASA's Kepler Space Telescope, this exoplanet sits about 600 light-years away, a mere stone's throw in galactic terms. What makes Kepler-22b so compelling, so worthy of our immediate attention, is its location, squarely within its star's habitable zone. This is the Goldilocks zone, not too hot, not too cold, but just right for liquid water to potentially exist on its surface. Kepler-22b receives about the same amount of stellar radiation as Earth, maybe a little less, suggesting that if it has an atmosphere, and that's a big if we're working to answer, it could maintain temperatures conducive to vast oceans. Imagine a world where water isn't just a feature, but defining characteristic, a true water world. Kepler-22b is a super-Earth, roughly 2.4 times the radius of our home planet. Its mass is still a bit of a mystery, but it's likely significantly more massive than Earth. This larger size could mean a stronger gravitational pull, potentially allowing it to hold on to a thicker atmosphere. A denser atmosphere could provide better protection from harmful stellar radiation and help regulate surface temperatures, creating a more stable environment for life to emerge and evolve over billions of years. Now let's journey to a place that is the polar opposite of the potentially clement Kepler-22b. Prepare yourselves because we're heading to 55 Cancri E, a planet that can only be described as a vision of hell, a true inferno world. Located about 41 light-years away in the constellation Cancer, this exoplanet orbits incredibly close to its star, 55 Cancri A, completing a full year in a mere 18 Earth hours. Imagine that, your birthday, every single day, but you wouldn't want to celebrate it here. This proximity means 55 Cancri E is tidally locked, just like our moon is to Earth. One side permanently faces its star, enduring an eternal blistering day, while the other side is locked in perpetual night. The dayside temperatures are estimated to soar above an unimaginable 4,400 degrees Fahrenheit, or about 2,400 degrees Celsius. That's hot enough to melt rock, hot enough to vaporize most metals. We're talking about a surface that likely glows with its own incandescence, a planet literally on fire. The conditions are so extreme that scientists believe much of its surface is a roiling ocean of lava. Imagine vast seas of molten rock bubbling and churning under the relentless stellar heat. Based on its density and composition, scientists have theorized that this super-Earth, about twice Earth's radius and 8 times its mass, could be incredibly carbon-rich. So rich, in fact, that a significant portion of its interior, perhaps even its mantle, could be made of diamond. Yes, you heard that right. A planet with a diamond core or vast layers of diamond forged under immense pressure and heat. Talk about a treasure chest. So while the surface is a molten nightmare, the interior could be a glittering wonder. Chapter 3. WASP-12b, the planet being eaten alive. Our next destination, WASP-12b, presents a different kind of extreme, a cosmic tragedy unfolding on a planetary scale. This is a hot Jupiter, a gas giant orbiting perilously close to its parent star, WASP-12, which is located about 1,400 light-years from Earth. And when I say close, I mean close. WASP-12b completes an orbit in just over 1 Earth day. This proximity has profound and rather grim consequences for the planet. One of the most striking features of WASP-12b is its incredible darkness. This planet is one of the darkest exoplanets ever discovered, absorbing at least 94% of the visible starlight that falls upon it. It's blacker than fresh asphalt, a true light eater. The reason for its profound darkness is thought to be its extremely high temperature, so hot that molecules like hydrogen can't even form clouds that would reflect light. Instead, its atmosphere is likely composed of atomic hydrogen and helium. The temperatures on WASP-12b are, as you might expect, astronomical. We're talking about day-side temperatures reaching over 4,600 degrees Fahrenheit, or around 2,500 degrees Celsius. At these temperatures, even molecules are torn apart. It's so hot that it glows with its own heat, radiating in the infrared spectrum like a hot coal. This intense heat also causes the planet to be significantly puffed up, much larger in radius than Jupiter. Even though its mass is only about 40% greater than Jupiter's, it's a bloated behemoth, stretched to its limits. But the most dramatic aspect of WASP-12b's story is that it's being actively consumed by its star. The star's immense gravity is stripping away the planet's atmosphere at an alarming rate, something like 6 billion metric tons per second. The planet is literally being devoured, its material forming a vast, superheated disk around the star. Chapter 4, Kepler-16b, the Real-Life Tatooine. For our final stop, let's venture to a world that might just pluck a string in the heart of every science fiction fan. I'm talking about Kepler-16b, a planet that orbits not one, but two suns. Yes, a circumbinary planet, a real-life Tatooine, the desert homeworld of Luke Skywalker from Star Wars. This remarkable system is located about 245 light-years from Earth, and its discovery confirmed that planets can indeed form and maintain stable orbits in such complex gravitational environments. Imagine standing on the surface of Kepler-16b and witnessing a double sunset or a double sunrise. The sky would be a constantly shifting canvas of light and shadow as its two parent stars, one a K-dwarf, smaller and cooler than our sun, and the other a red dwarf, even smaller and cooler, dance around each other in a 41-day orbit. The planet itself orbits this binary pair every 229 Earth days. It's a celestial ballet of incredible precision. Kepler-16b is a cold, gaseous planet roughly the size of Saturn, composed of about half rock and half gas. Because its stars are cooler and less luminous than our sun, and because the planet orbits them at a distance comparable to Venus's orbit in our solar system, Kepler-16b is quite chilly. Surface temperatures are estimated to be in the range of -100 to -150 degrees Fahrenheit, or -70 to -100 degrees Celsius. So while it might offer spectacular views, it's not exactly a hospitable beach destination. The question of habitability for circumbinary planets like Kepler-16b is complex. For a long time, astronomers weren't sure if stable planetary orbits could even exist around binary stars, or if planets would be quickly ejected by the chaotic gravitational tug-of-war. Kepler-16b proved they can. So, from potential water worlds to diamond infernos, from planets being devoured by their stars to those basking in the light of twin suns, the cosmos is indeed a place of infinite variety and wonder. The universe is full of weird planets, and we've only just begun the search. Each discovery we've touched upon today is a testament to human ingenuity and our unyielding curiosity to understand our place among the stars. These exoplanets are not just distant points of light, they are laboratories of cosmic evolution, challenging our theories and expanding our horizons. The sheer number of exoplanets already found, with thousands more candidates waiting for confirmation, statistically implies that we are on the cusp of even more breathtaking discoveries. Somewhere out there, a planet might be teeming with alien life, right now. It could be on a world like Kepler-22b, or perhaps on a moon orbiting a gas giant in a binary star system, or even in an environment so bizarre we haven't yet conceived how life could thrive there. The possibilities are as vast as the universe itself. The quest continues.